Hello viewers, welcome to another episode of Knowledge Sharing. Before continuing, like and follow our Facebook page, subscribe to our YouTube channel, comment and share our video for more interesting topics. Today we are looking at this question and it says find all solution of x in x to the power of 5 minus 1 equals to 0. So here we are going to find the value of x in this given equation. So here we are given x to the power of 5 minus 1 equals to 0. If we have an equation like this is in the form x to the power of n minus 1 equals to 0. If you have equation like this, x to the power of n minus 1 is the same thing as x minus 1 into x to the power of n minus 1 plus x to the power of n minus 2 plus x to the power of n minus 3, then till you have plus 1, all equals to 0. So this is the format of the solution of x to the power of n minus 1 you have. So we have the same thing here, x to the power of 5 minus 1. This will give us x to the power of 5 minus 1 will give us x minus 1 into x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x to the power of 1 is the same thing plus x to the power of 0. All this equals to 0. So this is what we have. We can simplify this as x to the power of 5 minus 1 equals to, we have x minus 1 into x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1, because anything raised to the power of 0 is 1. That's why we have 1. All equals to 0. So now we have two parentheses here. It is either the first one equals to 0 or the second one equals to 0. So we take this one first. We have x minus 1 equals to 0, or we have x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1 equals to 0. So this first one, we have x equal minus 1 equals to 0. Therefore, x will be equals to 1 because minus 1 will be transposed into this other side. We have x equals to 1. This is the first solution of x. Then for the second one, we have x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1 equals to 0. For us to find the value of x or the solution of x in this equation, we have to divide all through by x to the power of 2. So we say divide all by x to the power of 2. So this will become x to the power of 4 all over x to the power of 2 plus x to the power of 3 all over x to the power of 2 plus x to the power of 2 all over x to the power of 2 plus x all over x to the power of 2 plus 1 all over x to the power of 2 equals to 0. So in this case, this will give us, this one will cancel here and this one will cancel here too. So we have x to the power of 2 plus this one will be x to the power of 1. Then this one plus, this one will cancel here and this one will cancel here. We have 1. Then plus, this one will cancel here and this one will cancel here 1. We have 1 all over x. Then we have plus 1 all over x to the power of 2 equals to 0. So this is what we have here. So here we have 1. If we say we replace 1 by 2 minus 1, it's the same thing as 1. So we are going to replace 1 by 2 minus 1 for us to make this place a square of a fraction. So this will become, when we put it there, we have x to the power of 2 plus x to the power of 1 is still the same thing as x. Then we have plus 2 minus 1. In the place of 1 here, we put 2 minus 1. Then we have plus 1 all over x. Then we have plus 1 all over x to the power of 2 equals to 0. So that is what we have. So here, we can group this and collect like terms. By rearranging, we have x to the power of 2. We have plus, bring this one here, 1 all over x to the power of 2 plus 2. Then here will still remain, we have plus x. Then we have plus 1 all over x. Then here will be minus 1 equals to 0. So this is what we have. We can group this here and here. We can group all there and we group here. So this will become x plus 1 all over 2 all to the power of 2. Then we have here plus x plus 1 all over x. Then we have minus 1 equals to 0. Here, we can see that when you expand this, it will give us this. Let's do that. Then we have this one will be x plus 1 all over x into x plus 1 all over x. So expanding this, x times x will give us x to the power of 2. X times 1 all over x will be plus x times 1 all over x. Then we have x 1 all over x times x, we have plus x times 1 all over x. Then we have 1 all over x times 1 all over x, we have plus 1 all over x squared. So in this case, this will become x to the power of 2 plus this one will cancel here and this one will cancel here. We have 1 plus 1. Then we have plus 1 all over x to the power of 2. Here will become x to the power of 2 plus 2 plus 1 all over x to the power of 2. You can see that this is the same thing as having this. So that is why we have this. So we have succeeded in proving that. So we all understand why we bring in this. So in this case, we can see that we have x plus 1 all over x here, and we have x plus 1 all over x. So we say let u equals to x plus 1 all over x. So in this case, we replace this, we have u plus, this is u squared plus u minus 1 equals to 0. So in this case, this is a quadratic equation, and we are going to use a quadratic formula to find the value of u. So in this case, we have our x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. In this case, we have a value of a equals to 1 and b equals to 1 and c equals to minus 1. Substituting this parameter into this equation or this formula, we have x. So in this case, the value of our x here will be equals to minus 1 plus or minus, we have square root of 1 squared is 1 minus 4 times 1 times minus 1, we have minus 4. So this will become minus minus, which is plus 4 all over 2. So in this case, we have minus 1 plus or minus square root of 5 all over 2. So this is the value of x. So in this case, this is the value of our x. No, it was the value of u because we are looking for u here. So here will be u, and here will be u, here will be u. So here, our value of u here is this. So we say that u equals to x plus 1 all over x. Therefore, we have u as minus 1 plus or minus square root of 5 all over 2. So we move over to this other side. We have our u equals to minus 1 plus or minus square root of 5 all over 2. So we say here u equals to this. So u equals to x plus 1 all over x. So in that case, equating these two, we will have x plus 1 all over x equals to minus 1 plus or minus. We take one after the other. We are going to take the first one, which is plus, because so we have two solutions in this u. So we take plus first, which is plus root 5 all over 2. So solving this, for the left hand side, we take the LCM of these two, which is x. So we have here x. So this is like x all over 1. So x divided by 1 is x. X times x, we have x to the power of 2. So plus x here, 1. 1 times 1, we have 1, equals to minus 1 plus root 5 all over 2. So in this case, we are going to cross multiply. So 2 times here will be 2 into x to the power of 2 plus 1 equals to x into minus 1 plus root 5. So expanding this, we have 2x to the power of 2 plus 2 equals to minus x. X times minus 1 is minus x plus root 5. That is x root 5. So this is what we have. So in this case, we are going to collect like terms by moving all this to one side. So it will become 2x to the power of 2 plus 2. Then this one moves to this other side. We have plus x minus x root 5 equals to 0. So in this case, we have x here and we have x here. It's common, so we can factor it out. So we have 2x to the power of 2 plus x into 1 minus root 5 equals to 0. So here, let's rearrange this because this is a constant. It is a quadratic equation in this form. 2 x to the power of 2 plus x into 1 minus root 5 plus 2 equals to 0. So we have a quadratic equation here where we have x to the power of 2 and we have a constant of x here as 1 and also have constant here. So we are going to use a quadratic formula for us to derive the value of x in this equation. So we have from the equation that we have x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So now we have from here we have our value of a. Value of a equals to 2. Then value of b equals to, for b here we have 1 minus root 5. Then our value of c equals to 2. So substituting that parameter into where we have this. So our x equals to minus b. Our minus b is 1 minus root 5. Then we have plus or minus. We have square root of our b squared is minus 1 root 5 all to the power of 2. Then minus 4 times a. Our a is 2. Then times 2. Our c is 2. All over 2 times 2, which is 2 for a. Then we have x equals to, this will become minus times 1 is minus 1. Then minus times minus root 5 will come plus root 5. Then we have plus or minus. We have square root of, so this is the same thing as when we have 1 minus root 5 squared is the same thing as 1 minus root 5 into 1 minus root 5. So expanding this, 1 times 1 will give us 1. Then 1 times minus root 5 will give us minus root 5. Then we have minus root 5 times 1 minus root 5. Then we have minus root 5 times minus root 5 will give us plus 5. So here will become 1 minus 2 root 5 plus 5. So this is what we have. For here, we put it here. So here will become 1 minus 2 root 5 plus 5 minus, here is 4 times 2 times 2 become 16. All over 2 times 2 we have 4. So that is what we have from now. So this is what we have. So here we can further simplify this as x equals to minus 1 plus root 5. We have plus or minus square root of, here is 1 plus 5, we have 6. Then 6 minus 16, we have minus 10. So this will become minus 2 root 5 minus 10 all over 4. So in this case, we have this as x equals to minus 1 plus root 5 plus or minus. Here, this will become root square root of minus into 2 root 5 plus 10 all over 4. So this is what we have. So now, this is the same thing as x equals to minus 1 plus root 5 plus or minus. We have it, here is root, this is the same thing as root 2 root 5 plus 10 times minus 1. So this is what we have. So it's the same thing as, this is all over 4. Because we have root minus 1, we can write it as times root minus 1, which is equals to iota. So here we can rewrite that as x equals to minus 1 plus root 5 plus or minus square root of, we have this as 10 plus 2 root 5 I all over 4. So this is what we have for x. And here, this solution, we have two solutions inside this place. So the next one for the case 2, which is, because the first one that we've taken was plus, we are going to take minus for the case 2. So this is for case 1. So we need to clean this. Then here, this is for case 1. Then we have case 2. We are taking the negative side where u equals to minus 1 minus root 5 all over 2. Our u equals to this. So we have x plus 1 all over x equals to minus 1 minus root 5 all over 2. So in this case, the same thing that we did there, if we solve for x here will be equals to minus 1. This place, in the place of plus, we have minus root 5 plus or minus, we have square root of 10 plus 2 root 5 I all over 4. So here, this is second part, which is case 2. So in this case, we have two solutions here. These two solutions here, let's call the first one we had x equals to 1. This is for x1. Then the second one we have here, which is x2 here and x3, which is equals to, because we have two solutions here, root 5 minus 1 plus or minus square root of 10 plus 2 root 5 I all over 4. So this is for x2 and x3. Then this one is going to be x4 and x5 will give us this. So these are the possible solutions: x1 here, x2 and x3, which is this, and x4 and x5, which is this. So these are the possible solution of x that satisfy this expression. We can do a little check for us to see whether when we have x equals to 1 will give us 0. So we are going to clean this for a little check that we have x equals to 1. Then our equation says that we have x to the power of 5 minus 1 equals 0. When x equals to 1, we have 1 raised to the power of 5 minus 1 gives us 0. 1 to the power of 5 is 1. Therefore, we have 1 minus 1 equals to 0. So 0 equals to 0. What we have on the left-hand side is what we have on the right-hand side. Therefore, x equals to 1 satisfies this question. And so doing, x2, x3, x4, and x5 will also satisfy the question. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comments, and share our video for more interesting topics. Thank you.